Hello everyone! Today I'm going to demonstrate to you how you can map a floating point or a real number on a Wonderware. The platform that we're using is going to be on Wonderware InTouch, and the PLC that we're going to read from will be from Schneider's Modicon M580. So let's start by launching our system management console here. We click here, you type system management console. So that's your system management console right there. So let's drill down here, go to local and go to your DB TCP, and you'll see diagnostic here. And we'll keep the screen open here. This is where all the logs will be displayed here as we read all the Modbus registers. The next thing we want to launch is our Wonderware InTouch. Okay, we just launched our window maker, and we've got this display here, a screen that we're going to show the value that is being read. So what I'm going to do is I'm going to run this. I've got nothing here, but I'm going to run it anyways. Runtime. There you go. I've got a runtime environment here. So I've got the Windows Maker here. I got the runtime environment here, and I've got SMC looking at all the Modbus address that we are pulling from the PLC. Next, I'm going to bring up the PLC program here. I'm going to launch Control Expert. So here's the programming environment for the PLC called Control Expert. This is for the Modicon 580. So let's create one variable called, say, ZZZ Skynet tests, and I'm going to call this a real. Like here. So there's two ways of doing it. One way is just assigning an address here, just like that. See, I'm going to choose a Modbus address, say 2526. Right, so it's reading 40,025.26. You can do it this way and map it backward. I'm going to show you another way to do it. Just going to delete this guy here. Another way to do it is to write a program here. So first of all, what you do is that you convert you're going to need this function block called real as word. Put it in. Just going to zoom out a bit less. So you're going to put in a real. That's your ZZ, that variable there. And then what you're going to do is that this is going to spit out the word. But what you have to convert that is into int. So you're going to need another one called word to int. So you now have that. So you can connect this to here. You need another one more here. Connect that to that. A bit close here. And then over here on the outside, we did say we're going to read the register address, say MW, which is 40,000. Sorry, percentage. MW 40,000. When you say MW means memory word, like 40,000, or Modicon word. I don't know what the MW stands for, but MW, which means 40,000, 2526. That's your first register of your 32-bit floating point. And the second register would be here, which is 27. Right, so this is how you do it. So you got your tag, you got that. And then next thing you want to do is you're going to build it. Okay, next you're going to go set address, set your IP address of PLC, connection type, test connection. Successfully connected. Then you go PLC connect. And now after it's connected, you click on PLC, you'll see a disconnect, which means it's successfully connected. Now you're going to transfer the program to the PLC. Okay, you're done. Gray screen means that you're online with a PLC. So it's 0 right now, spitting out 0, 0 integer. Now, next thing we're going to do is you're going to add a widget here to display the floating point value here. So you're going to click on this T here, text, pound, 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 dot, 0, pound, 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 which indicates a number of spaces and whatnot. We are showing decimal. We are showing a real value. That's why you got to change the font size to make it bigger. Something more legible, I guess. Let's do it that way. If you right click animation or double click it, it'll bring you to this. You want an analog display. I've already created this tag here, but let's see what this tag entails. So I have this tag. So give it a name, whatever name you want. IO type would be real. If you go in there, and then give some description, and then the PLC that you're trying to pull from, and then the floating point values, I guess, here. So I'm reading. If I pull up my PLC program again and go offline here for a sec. So I'm reading from Modbus, starting with Modbus 2526. So it's 40,000, 25, 26. But Modicon is a zero-base Modbus address, so they're always one lesser. So when you map it to your Wonderware, you're gonna have to plus 1. So you have you're trying to read Modbus address 2526 and 2527. You have to map 2527, and this will be reading 2527 and 2528. Another thing that you have to know is that when you map the 40,000 floating point, you got to put an F at the back. And one more thing you have to know is that it starts at 40. You got to put 0 here. Although I say Modbus says it's 40,000 register, but somehow when you map it, you got to put a 0 here. Okay, so I'll show you the effect of min max EU first here. So it's right now 0 to 100, 0 to 32,726. So you save it, close, hit OK, and then you save it again. File, save. Once you save it, this gets updated. And if you scroll down here to 40,027 here, this guy here, it's not being read yet. That's why I'm showing exclamation yet. So as soon as this thing refreshes, this will show you a value here. And you'll realize that the values here matches the Modicon. Okay, let's do something here. Okay, just hold on. I'm gonna build it. Get online here again. So I'm gonna monitor this guy here. So right now it's showing 0. So if I were to, you gotta click this to modify. Make sure it's blue. If I say 123.45, oops. 123.45, you hit enter, you'll see that this matches this guy, but it doesn't match this for some weird reason, right? This is due to the fact that the scaling is incorrect on Wonderware. It's funny because this SMC, the DAS MDB TCP reads whatever is being set as a floating point, but this guy does scaling on his own terms. So in order to mitigate that, we double click this guy here, go back to your tag dictionary for this one here. What you have to do is to copy, gotta do that, and then you gotta make it exactly the same. If you do that, it will assume that no scaling is required, or rather they are equal word for word, and they will show you whatever is necessary. I guess whatever this thing value is being shown here. I'm gonna save it. File, save. And you can see that this matches once the polling is done. You can see that the programming environment matches the SMC Modbus TCP driver, and that matches as well. All right, so if I can try changing it to say something else. Something like that. See how quickly it comes back. One more test. There you go. That's how you take the Modicon PLC's Modbus address, map it to SMC, and back to the Wonderware InTouch. I hope this quick little tip helps you. Anyway, have a nice day. Bye.